Today we have to discuss inverse Laplace transforms. So we know the Laplace transform of a function f of t. So if L of f of t equal to f of s, then f of t is the inverse Laplace transform of f of s and is denoted by L inverse f of s equal to f of t. So next, linearity property. L inverse of A into f of s plus b into g of s equal A into L inverse f of s plus b into L inverse g of s. So next we have to define inverse transform of some elementary function. We know the Laplace transform of some elementary function, that is if L of 1 equal to 1 by s, then L inverse 1 by s equal to 1. Second one, L of t equal to 1 by s square, then L inverse 1 by s square equal to t. Third one, L of t raised to n equal n factorial by s raised to n plus 1, then L inverse 1 by s raised to n plus 1 equal t raised to n by n factorial n equal 1, 2, 3, etc. Fourth one, L of e raised to at equal 1 by s minus a. Then L inverse 1 by s minus a equal e raised to at. Fifth one, L of e raised to minus at equal 1 by s plus a. Then L inverse 1 by s plus a equal e raised to minus at. Sixth one, L of sin at equal a by s square plus s square. Then L inverse of 1 by s square plus s square equal sin at by a. And seventh one, L of cos at equal s by s square plus a square. Then L inverse of s by s square plus a square equal cos at. Eighth one, L of sin h at equal a by s square minus a square. Then L inverse of 1 by s square minus a square equal sin h at by a. And ninth one, L of cos h at equal s by s square minus a square. Then L inverse of s by s square minus a square equal cos h at. So next we have to define the shifting property of inverse transform. If L of f of t equal to f of s, then L of e raised to at f of t equal f of s minus a. Therefore, L inverse of f of s minus a equal e raised to at into f of t. Important, L inverse of f of s minus a equal e raised to at into f of t. So, next we have to discuss some problems. So, first one is find the inverse transform of, first question is s square minus 3s plus 8 by s cube. Second one is 8 by s minus 1 minus 3 by s plus 6. And third one 3s plus 2 by s square plus 9. So first one is L inverse of s square minus 3s plus 8 by s cube can be written as L inverse of s square by s cube as 1 by s. It is L inverse of 1 by s minus 3 by s square plus 8 by s cube. Using linearity property, this can be written as L inverse of 1 by s minus 3 into L inverse of 1 by s square plus 8 into L inverse of 1 by s cube. So equal to, we know L inverse 1 by s is 1. So 1 minus 3 into L inverse 1 by s square as t. So minus 3t plus 8 into L inverse of 1 by s cube as t square by 2 factorial. So the answer is 1 minus 3t plus 4t square. And the second one is L inverse of 8 by s minus 1 minus 3 by s plus 6. So using linearity property, this can be written as L inverse of 8 by s minus 1 minus L inverse of 3 by s plus 6. So here 8 is constant, then take outside 8 into L inverse of 1 by s minus 1 minus, then 3 is constant, take outside 3 into L inverse of 1 by s plus 6. So this equal 8 into, and we know L inverse of 1 by s minus 1 is e raised to t. 8 into e raised to t minus 3 into e raised to minus 60. And third one, L inverse of 3s plus 2 by s square plus 9. And using linearity property, this can be written as L inverse of 3s by s square plus 9 plus L inverse of 2 by s square plus 9. So here 3 is constant, then take outside 3 into L inverse of s by s square plus 9 plus 2 into L inverse of 1 by s square plus 9. So that is equal 3 into, what is L inverse of s by s square plus 9? 9 can be written as 3 square. So L inverse of s by s square plus 3 square, that is cos 3t, plus 2 into L inverse of 1 by s square plus 3 square can be written as sin 3t by 3. So the answer is 3 cos 3t plus 2 into sin 3t by 3. So the next problem is, find the inverse transform of 1 by s square plus 6x plus 18. So here first we can convert the denominator as a perfect square. The method is that first we consider the coefficient of s, here that is 6. Then take half of the coefficient of s, that is half into 6, that is 3. And take the square, that is 9. We add and subtract 9 in the denominator. So L inverse of 1 by s square plus 6x plus 18 can be written as L inverse of 1 by denominator s square plus 6x plus 9 minus 9, then plus 18. Add and subtract 9. So we consider the first 3 terms, that is s square plus 6x plus 9. It can be written as s plus 3 whole square. So is equal L inverse 1 by s plus 3 whole square plus minus 9 plus 18, that is plus 9. So it can be written as L inverse of 1 by s plus 3 whole square plus 9 can be written as 3 square. So what is its inverse transform? Then using shifting property, the answer is e raised to minus 3t. Here the denominator is s plus 3 whole square. So the answer is e raised to minus 3t into sin 3t by 3. The next one is, find the inverse transform of 3s minus 2 by s square plus 2x plus 6. Here also, first we convert the denominator into a perfect square. So we consider the coefficient of s, that is 2, and take half of the coefficient of s, that is half into 2 is equal to 1, and take its square, that is 1 square. 1 square is 1 itself. So we add and subtract 1 in the denominator. So L inverse of 3s minus 2 by s square plus 2x plus 6 can be written as L inverse of 3s minus 2 divided by s square plus 2s plus 1 minus 1, then plus 6. And we consider the first 3 terms, s square plus 2s plus 1. It can be written as x plus 1 whole square. So this equal L inverse of 3s minus 2 divided by s plus 1 whole square plus 5. So equal to, here the numerator 3s minus 2 can be written in terms of s plus 1. So that is equal L inverse of 3 into s plus 1 minus 5 divided by s plus 1 whole square plus 5 can be written as root 5 whole square. So this equal L inverse 3 into s plus 1 by s plus 1 whole square plus root 5 whole square minus 5 into L inverse 1 by s plus 1 whole square plus root 5 whole square using linearity property. So this equal, here 3 is constant, take outside, 3 into L inverse of s plus 1 by s plus 1 whole square plus root 5 whole square. So the formula is e raised to minus t into cos root 5t using shifting property minus 5 into, and using shifting property, what is its value? E raised to minus t into sin root 5t divided by root 5. So this equal 3 into e raised to minus t cos root 5t minus, here 5 can be written as root 5 into root 5, and 1 root 5 cancel. So root 5 into e raised to minus t into sin root 5t. So which is the final answer. So, so there are 3 problems. Do it as homework. find the inverse transform of the following. First one is 3 by s plus 5 by s cube minus 2 by s plus 4. Using linearity property, split into 3 terms and find the inverse Laplace transform. And the second one is s by s square plus 6x plus 25. So here we convert the denominator into a perfect square and take the inverse Laplace transform. And similarly, third case, 12 by s raised to 4 minus 288 by s raised to 6. Using linearity property, split into 2 terms and find the inverse Laplace transforms. Okay.